Can we find the derivative of this? Let's take a look. So we have y equals x squared plus 1 to the power of x. Find the derivative of that. So when you have an exponent like that, we are going to use what's called logarithmic differentiation. Okay? All right, let's see. So the strategy is logarithmic differentiation because we want this exponent to be brought in front of the function over here. Why? Because that'll be much easier for us to take the derivative off to become a product, use the product rule. So let's take ln on both sides. Then ln of y, ln of x squared plus 1, this exponent comes to the front. As we said, power rule of log. So ln of I is x ln x squared plus 1. Now we're going to differentiate both sides with respect to x. Okay, on the left hand side we have ln of y, so which is differentiate that gives us 1 over y dy dx. Okay, so because we have the outer function L over y that gives 1 over y and the inner is the y, so that's dy dx. That because derivative of ln of y is 1 over y, and we are going to use the chain rule for the rest of it. Okay, so dy dx. Right hand side we're just going to use a product rule. So the derivative of x times this plus the x times the derivative of the other part. Okay, good. So derivative of x is 1. And here we have derivative of ln x squared plus 1 is 1 over x squared plus 1. And then the inner function we have to differentiate, which is 2x. Okay, so this is outer and then inner. So now we are left with ln x squared plus 1 plus 2x squared divided by x squared plus 1. We just multiply these. And this is basically what we have on the right hand side. On the left, we have 1 over y dy dx. So now what we're going to do is we want to solve for dy dx, okay, to get y prime. So y can be brought over to the other side. I'll cross multiply, and then we're going to write the rest of it ln x squared plus 1 plus 2x squared divided by x squared plus 1. Now let's go ahead and substitute the y, which is the original function, which is y equals x squared plus 1 to the power of x. So when we substitute that, we have x squared plus 1 to the power of x and everything inside right here that we just spoke of. So this is our final dy dx. This is the derivative of that function that we began with. And now the graphical explanation is, you see this is the red is the original, the purple is the derivative. You see where the slope of the original function is 0, the derivative is 0. More or less the derivative is positive most of the all the graph, but the slope of the derivative gets negative and positive. But there's a point where there's a change of concavity, and that's where the max slope is present, right? So as the slope increases, you get more and more higher positive derivative. As the slope gets less steep, the slope of the derivative gets negative. The derivative itself is positive. Okay, and then here also, as the derivative gets, as the original function gets steeper, the derivative increases more and more positive. All right, hope you enjoyed this video. I'll talk to you in the next video. Let me know if you have any questions. Have a nice day. Bye.